Everyone keeps speculating that Proxima B might be another Earth-like planet. Humans are fascinated by the hunt for extraterrestrial life on other worlds and the search for another habitable planet. Numerous theories have been put forth, and the fact that Proxima B has sent out signals leads some to assume there is more to it. We have yet to ascertain whether these are echoes of our own signals or messages from the planet, despite all these indications. Signals from scientists frequently become echoes. Scientists want to know if there is extraterrestrial life by figuring out if these signals are actually coming from Proxima B. Artificial lights were recently observed on Proxima B by the James Webb Telescope. Subscribe to our channel to find out more about other planets and our progress in locating extraterrestrial life. We create space-related content and discuss scientific advancements. Please leave a comment below and tell your friends about this video if you enjoy it. Let's return to our video now. Proxima Centauri, also known as Proxima Centauri, is a dim dwarf star with a GV classification that is located around 4.2 light-years away from our solar system. The star is the one nearest to our solar system and sun. In 1563, Johann Bayer gave it the horological name Alpha Centauri. The name was derived from the fact that the star rose at midday while the sun, moon, and other celestial bodies were all in a straight line. Alpha Centauri A or Alpha Centauri are other names for Proxima Centauri. Proxima Centauri is at the core of this single star system, which consists of 4 primary stars arranged in a line. Alpha Centauri A, also known as Rigel Kentaurus, and Alpha Centauri B are 2 dim dwarfs in addition to the 4 stars. Although they are too faint to be seen with the naked eye, these comprise the majority of the mass. The system is situated in the Centaurus constellation, 2.3 light-years from the edge of the well-known Plough asterism. There is still optimism that Proxima B, despite being a hard planet, could harbor extraterrestrial life. Scientists have arrived to Proxima B in an effort to find any other life in the universe. They think it's a good choice for planets that can support life because of its size resemblance to Earth and its separation from its dwarf star. Even though all of them are conjectures, there is hope that some of them may be true. Be sure to keep checking back to learn more about Proxima B and its orbit. Additionally, you can look through some of our other alien-related content. Is there another life out there, in your opinion? Comment in the space provided below. Most people find Proxima B fascinating because of how much it resembles Earth. According to studies, Proxima B is an exoplanet with a mass 1.27 times that of Earth that circles a M-type star. In addition, it takes Proxima B 11.5 days to complete one circle around its star. Numerous scientists are investigating this discovery, which was made in 2016. Despite having a similar appearance to Earth, Proxima B is inhospitable due to specific traits. One reason is that the planet is too near its star, which causes it to constantly receive intense UV radiation. It is thought to be hundreds of times more than the sun's radiation. Even the lightest hydrogen molecules are stripped away by the intense radiation. With time, oxygen and nitrogen are also stripped away. There is more to Proxima B than meets the eye, despite the fact that most people would contend that it should be habitable because it is the same distance from its star as Earth is from the sun. The existence of water on the planet is not taken into account by distance. Additionally, there is no proof that there is an atmosphere that supports life. Earth's atmosphere, not Mars, is what makes it habitable. A water-friendly surface and climate regulation are made possible by the proper atmosphere, which also protects living things from dangerous space weather. Please take a moment to click the subscribe button if you haven't already. It will help us continue producing content that you will enjoy. Let's now examine the reasons behind the belief that the James Webb Telescope will aid in the determination of whether life exists on Proxima B. After being postponed since 2011, the James Webb Telescope was finally launched in 2018. To guarantee that it produced accurate photos, numerous adjustments had to be performed. If a planet like Proxima B could absorb light from its star, it could also re-emit it as infrared light, Loeb explained during development. The purpose of the James Webb Telescope's invention was specifically to observe infrared light. It can capture images of this light on a planet's surface and search for trends that could indicate if the planet has an atmosphere or water. Being above the atmosphere allows space telescopes to see far into space without having to look through the moving air, which is one of the reasons they are chosen over ground-based ones. As a result, They are able to see more of the outer solar system than is possible with most ground telescopes. They also have the benefit of being unaffected by fluctuations in Earth's weather, so astronomers can be certain they're receiving a clear reading. The sole drawback of owning a space telescope is the high cost of repairs. In certain instances, a minor malfunction necessitates sending an entire crew into orbit to fix it. It is challenging to observe planets like Proxima B because of these expenses. Since the James Webb Telescope was launched more than 1.5 million kilometers away, further than any human has ever traveled, rescue efforts are not an option. We can see all the way back to the beginning of the universe, nearly 13.7 billion years ago, thanks to the bigger mirror that the James Webb Telescope has. We can observe an object farther in time the farther away it is. Because light takes a long time to return to us from an object, this is the case. We can now view more distant galaxies in our universe with greater certainty than before thanks to the James Webb Space Telescope's capacity to see the universe in infrared light, which has a longer wavelength. This has pushed the light into the infrared and out of the visible spectrum, making it simpler to observe planets like Proxima B. The artificial illumination scale developed by Tabor and Loeb represents a percentage of the sun's light and reflection on the planet's day side. One would think that the planet's night side is utterly dark and unlit at 0% on the scale. It indicates that the planet's night side is as brilliant as its day side when it is at 100%. This kind of light was used by a fictitious society on Proxima B, and most scientists think it is comparable to the early Earth's history. According to the studies, the James Webb Telescope might detect the artificial light by 85% if the night side of Proxima B reaches an illumination of 5% of the natural day side. The telescope would detect up to 95% if the illumination reached 9%. We are discussing the light from a star as far away as Proxima Centauri is from our Sun. We have an illumination that is 20,000 times dimmer, but we still have a lot of light from our star, even though 5% illumination may seem like a small amount. This essentially indicates that we are still reflected in the stellar illumination at 0.1% of illumination. In other words, the James Webb Telescope would not discover any hidden civilization on Proxima B that glows like Earth. The brightness of the stars would have to increase by almost 500 times. Since Proxima B orbits so near to its host star, this scenario is not possible. Instead, it may be tidally locked, which means that one side of the planet is always facing the star while the other is in perpetual darkness. In order to reflect sunlight from the planet's day side to its night side, a civilization on a tidally locked planet might need to concentrate on lighting infrastructure and employ extremely bright orbiting mirrors. Tabor and Loeb made all of these conjectures, and there is currently no evidence to support them. Airglow is the term for the illumination of the Earth that is visible from space. When looking at the world from 300 miles above the ground, most people marvel why it is surrounded by vivid red, yellow, green, and purple light. When extra energy is released by atoms and molecules in the upper atmosphere, light is produced, which causes the airglow. When sunlight ionizes atoms and molecules and captures free electrons, the airglow can occur on Earth. Despite the fact that auroras are powered by high-energy particles from the solar wind, the glow appears to be comparable to one. Every day, solar energy drives the airglow. Ever since the launch of the James Webb Telescope, astronomers have questioned if it is enough to see other planets in distant galaxies. Despite being the farthest satellite telescope ever launched, it still only offers a small amount of the information required to locate habitable planets in distant galaxies. Consequently, discussions on creating larger and more advanced telescopes have taken place. These endeavors are frequently expensive and require a great deal of trial and error. These problems caused the launch of the James Webb Space Telescope to be delayed by 7 years. As a result, most scientists find it difficult to create better inventions that can be sent farther into space. The results from the James Webb Space Telescope are encouraging in spite of this. We may soon be able to determine whether Proxima B and other planets are home to life. Although additional telescopes are constantly being developed, it is thought that space research will undergo a revolution with the completion and launch of the Habitable Exoplanet Observatory. HabEx is anticipated to be finished by 2035, with a launch scheduled shortly thereafter. Although HabEx's primary goal is to find planets that resemble Earth, it will be sensitive to all planets in the cosmos. It will be able to assess the habitability of most planets by measuring their spectra thanks to its sophisticated technologies. Additionally, HabEx is thought to possess a wide range of astrophysical capabilities. With the help of this capability, HabEx will be able to collect data, investigate the earliest periods in the history of the cosmos, and learn about the life cycles and demises of huge stars, as well as the components that sustain life as we know it. The technology utilized to create HabEx will enable it to study Earth-like planets with such high resolution that the photographs from these planets will be exceptionally clear, despite the fact that HabEx is still in production. HabEx will be susceptible to optical, near-infrared, and ultraviolet light. HabEx has an intriguing proposal that will revolutionize space research. HabEx seems like an ambitious idea, and space research will change if it succeeds. More details about extraterrestrial life on other planets will be available soon. Because it can see back many more years before the world's civilization and climate changes occurred, it also gives a better image of Earth. Although LUVOIR's concept is a scaled-down telescope, it nevertheless expands upon the James Webb Space Telescope's capabilities. With its UV capabilities, it is regarded by the majority of astronomers as the next observatory telescope to be employed. Scientists intend to launch HabEx and LUVOIR at the same time. Space research will be substantially improved by the large UV optical Earth surveyor. It will be able to comprehend what makes Earth unique. According to test studies conducted with LUVOIR, 28 planets that resemble Earth have been observed in a number of ways, with encouraging findings. Details about planets like Proxima B can become more obvious with the production of such telescopes. While the James Webb Space Telescope has made significant progress in revealing new information about Proxima B, much more remains to be done. The question of whether extraterrestrial life exists requires improved vision of other planets and a new perspective on atmospheres. It also examines the changes that have occurred over time and provides a deeper understanding of the planet's past. Have you ever wondered what might happen if we found life on other planets? Don't worry. Our channel features videos on this and a lot more. To receive notifications anytime we upload new content, subscribe to our channel and click the notification button. Does life exist somewhere besides Earth? For some time now, there has been discussion concerning extraterrestrial life. The majority of people think that the galaxy is not our only home. There have been assertions that have been verified for years and ideas that have been proposed. The type of research we do will determine whether or not we discover whether or not there is life on other planets. Because of this, researchers are trying to make sure that there are more space telescopes circling the Earth than other planets. To provide us with better answers on various planetary life, they must be more potent and look beyond infrared lighting. For the time being, we eagerly await the discovery of any life on our sibling planet Proxima B. Please subscribe to our channel if you enjoy this kind of video and would like to learn more about Proxima B and the James Webb Space Telescope. As we explore for life beyond Earth, we study telescopes, create videos every week, and examine evidence of Earth-like traits on distant worlds. If you think we're not alone in this cosmos, please like this video and comment below.